Hey guys, another 4.6 video here. We're going to talk about more about sequences and what types of sequences can I recognize is going to be our focus. So we're going to get into some kind of special sequences, more of the well-known, I was going to say popular sequences, I guess popular in the math world. And we're going to start with this one. This is a really well-known sequence. It starts with the number 1, and it goes 1, 2, 3, 5, 8, 13, 21, and 34. I'm going to challenge you here for a minute to see if you can pause the video and find what the next number in the sequence would be. Can you figure that out? Take a minute, see if you can figure it out. Okay, hopefully you're unpausing the video here and seeing if you can figure it out. This sequence, very well-known sequence, is called the Fibonacci sequence. And the way it works is it's adding the number previous in term to get the next value. For instance, the first two numbers are 1 and 1, and 1 plus 1 is 2. There's the next value. 1 plus 2 is 3. 2 plus 3 is 5. 3 plus 5 is 8, and so on. So to get that next number in the sequence, you would have to add 21 and 34, which makes 55. The next number you should have thought of is 55. And this famous sequence is named after a man with the name Fibonacci. Here he is. I'm going to tell you a little bit about who was Fibonacci. Some say he was the greatest European mathematician of the Middle Ages. He was fascinated by numbers. He kind of stumbled along this sequence almost by accident. And he's from this city. If you recognize that nice leaning tower of Pisa, this is Pisa, Italy. This is where he lived. Just for fun fact, and if you don't know where that is, the little red dot on the map shows you a picture of where in Italy Fibonacci lived. And he was kind of an interesting man. He had the opportunity to sail all around the Mediterranean Sea, so he went to a lot of different cities, met a lot of different people, and through his travels and studies, became a real mathematician. He just had this real, like I said, fascination with numbers, and he came across this sequence. And it's kind of interesting because the Fibonacci sequence is, interestingly enough, found in a lot of things in nature. For instance, a pine cone. If you've ever looked at a pine cone before, the pine cone has these things that go all the way around the little pokey parts. They're called bracts. And they go around and around and around. And if you were to count them, they actually go in the Fibonacci sequence. Same with pineapples. Pineapples are another great example, one of my favorite fruits. The pineapple's kind of like a pine cone. The Fibonacci sequence, if you count the bracts, if you go in the rings, it goes in the Fibonacci sequence. It's really interesting. Another good example is sunflowers. If you've ever gotten up to one of those like big sunflowers before and you've looked at like the seeds, you can go to the middle where there's one seed and you can start counting the rings and it goes in the Fibonacci sequence and it just keeps going. It's really interesting that we find all these different things in nature that just naturally happen that way. So this video today is not really to talk about the Fibonacci sequence. That's just kind of a famous one in the math world. But it's to tell you that there's usually two main categories that sequences can fall into. And we're going to talk about those two main categories. The first one, number 1, you better write this down in your notes, is called arithmetic. Arithmetic, and that's how you say that word. A lot of people want to say arithmetic, but no, we're not talking about arithmetic. Arithmetic is like adding and subtracting and multiplying and dividing. We're talking about a sequence, an arithmetic sequence. And I'm going to show you a couple of examples, but here's what you're going to write down. An arithmetic sequence is when you're always adding or subtracting the same value. It's a sequence or a pattern that involves adding or subtracting. So I'm going to give you an example that we can put in our notes here. 2, 5, 8, 11. 2, 5, 8, 11 is an arithmetic sequence. And the reason I know that is because when you count what it's going up by, what is it going up by? Yeah, it's going up by 3s. It's adding 3 each time. Plus 3, plus 3, plus 3. That's an arithmetic sequence because of the repeated addition. Another example I could give you is I could give you this thing. It starts with 3 and it goes -1, -5, and -9. This sequence is also arithmetic, and the reason is it's going down, but it's going down by 4s. It's taking 4 away, subtracting 4 each time. -4, -4, -4. That's an arithmetic sequence. So if you think about Fibonacci sequence, his is not arithmetic. It wasn't adding the same number every time. It was adding the number previous, which was different each time. His is not arithmetic. Arithmetic always add the exact same number each time, or subtract the exact same number each time. The second sequence that we often talk about is called a geometric sequence. Now, geometric sequences are similar to arithmetic, except instead of adding and subtracting, they are always multiplying or dividing by the same value. They're timesing or dividing by the same value. So again, Fibonacci sequence doesn't fall into this category either. His is unique. It's not arithmetic or geometric. Here's an example of a geometric sequence. 1, 3, 9, and 27. 1, 3, 9, and 27. Why is that geometric? Well, because it's multiplying by 3's each time you go up. Times 3, times 3, times 3, times 3. That's a geometric sequence. So easy example for you. I'll give you one more. Here's another example of a geometric sequence. The numbers are getting smaller. It goes 24, 12, 6, and 3. And how are they getting smaller? What are they doing? Well, they're dividing it. It's dividing the number in half. It's dividing by 2. So each time it goes divide by 2, divide by 2, divide by 2. That's geometric. All right, so now that we have that down, let's try a problem. We're going to do an example. And for our first example, I'm going to give you a sequence equation. I'm going to tell you that we have a sub n equals 4 to the nth power. A sub n equals 4 to the nth power. And we are going to answer some questions. The first question, I'll call it question A, is find the first 5 terms in the sequence. Find the first 5 terms. Okay, so we've done this in prior videos. We've practiced in class. That means we want A1, A2, A3, A4, and A5. And we know how to do that. We're going to take the 1, 2, 3, 4, 5, and we're going to put it in for n. So we're going to find 4 to the first power, 4 to the second power, 4 to the third, 4 to the fourth, and 4 to the fifth. And that's pretty easy for us to do. We just got to multiply those 4. That 4 to the fifth means you're going to have to do 4 times 4 times 4 times 4 times 4 5 times. But you can do that with your calculator if you want. Here's the values that you get. They get big pretty fast. 4 to the first power would be 4, then 16, 64, 256, and then like I said, they get big, 1024. So our first 5 terms are those numbers. And what I'm going to do is I'm actually going to change how I'm writing this. I'm going to put it in a brace. So it looks like this. 4, 16, 64, 256, and 1024 with the braces. Okay, so we've answered question A. We have the first 5 terms. That's kind of a previous skill, but here's question B. Is the sequence arithmetic or geometric? Or is it neither? Because sometimes it's neither. What do you think? Oh, I hope you're noticing that it is a geometric sequence. It's multiplying by 4 each time. Times 4, times 4, times 4, times 4. Totally a geometric sequence. And then last question here is what's the common difference between the terms? That means what's the common difference means what's being added or subtracted or multiplied or divided. In this case, it's timesing by 4. So the common difference is to times by 4. Okay, so your turn. Let's have you try one. Here is your sequence. A sub n equals 5 take away 4n. That's your equation. A sub n equals 5 take away 4n. I have the same 3 questions for you. Again, I'm going to make them A, B, C. First, can you find the first 5 terms in the sequence? And then can you decide, is it arithmetic or geometric, or is it neither? Sometimes it's none. And what is the common difference between the terms? Hit that pause button on your device and go ahead and give this a try. Good luck. Okay, you are hopefully all done answering the 3 questions. I hope you're unpausing the video and you're ready to actually check your solution. I'm going to go through what the answers are and you can look for any mistakes you might have made. The first 5 terms, your A1, A2, A3, A4, A5, end up being this. 1, -3, -7, -11, and -15. I put them in a brace. So hopefully you got the same thing. If not, you need to backtrack and check your math. The next question is it arithmetic or geometric? Or neither. Sometimes you can say none. This one, I hope you said, is arithmetic. It's totally arithmetic because it's subtracting 4 each time. It's going -4, -4, -4. So that answers question C. What's the common difference? Take away 4. That's the common difference, -4. Cool. All right, guys. So basically to wrap this up, there are 2 types of main sequences that we study in algebra, arithmetic and geometric. But there's definitely some unique sequences like the Fibonacci sequence. It doesn't fall into either of those categories. So you have to keep that in mind. Sometimes you'll be given a sequence and you'll be asked, is it arithmetic or geometric? And your answer might be, well, it's none. It might be something totally different. So kind of keep that in mind. All right, guys, thanks for watching the video. See you in the next one. Bye.